Welcome to School Page Video Teacher. Tenth CBSE Physics, Chapter Reflection and Refraction of Light. After watching this video, you will be able to understand what are the rules for obtaining images formed by spherical mirrors. In our previous video, we have understood what are spherical mirrors and types of spherical mirrors. In this video, let us understand what are the certain rules for obtaining images formed by spherical mirrors. We can study the formation of images formed by spherical mirrors using ray diagrams. Ray diagram is a simple method of representing in which direction the incident rays get reflected. So ray diagram can be defined as a diagram that traces the path that light takes in order for a person to view a point on the image of an object. So complex objects such as people can often be represented by arrows. We construct ray diagram to find out the position, nature, and size of the images formed by spherical mirrors. Position of the image means if this is the ray diagram, concave mirror, this is the principal axis, so in which position the image of the object is formed on the principal axis. Nature of the image means whether the image formed is a real image or virtual image. Size of the object means the image formed is diminished or magnified image. We know that an infinite number of rays originate from object. So if this is an object, there are infinite number of rays which are originating from the object. It is convenient to consider only two rays for the sake of clarity of ray diagram. These rays make it easy to know their direction after reflection from the mirror. Now let's understand the rules for obtaining images formed by spherical mirrors. In the first rule, a ray of light is incident parallel to principal axis. In the second rule, a ray of light is passing through the principal focus. The third rule, when a ray of light is passing through the center of curvature, The fourth rule, when a ray of light is incident at the pole. So first let us consider the first case when a ray of light is parallel to principal axis. First of all, let us draw concave and convex mirror. This is the principal axis. So this is a concave and this is convex. This is the pole. For a concave mirror, this is focus and center of curvature. Whereas for convex mirror, this is the pole, this is focus and this is center of curvature. When a ray of light is incident parallel to the principal axis for concave mirror, after reflection it will pass through the principal focus, as you can see here. So this is the incident ray and this is the reflected ray which is passing through the principal focus. Let's see what happens in the case of convex mirror. A ray of light which is parallel to principal axis appears to diverge from the principal focus. That is, this is the incident ray and the reflected ray appears to be diverging from the principal focus. The first rule is very clear that when a ray of light is parallel to principal axis for concave mirror, it passes through the principal focus. Whereas for convex mirror, a ray of light which is parallel to principal axis appears to diverge from the principal focus. In the second case, let's see in which direction a ray of light gets reflected when it passes through the principal focus. So this is a concave mirror which is curved inwards and this is the convex mirror whose reflecting surface is curved outwards. So this is pole, focus and center of curvature for concave mirror, pole, focus and center of curvature for convex mirror. So a ray of light passing through the principal focus of a concave mirror after reflection will merge parallel to the principal axis. That is, the incident ray which is passing through the principal focus after reflection will be parallel to principal axis. Let's see in case of convex mirror. When a ray of light which is directed towards the principal focus of a convex mirror, so you can see the dotted lines, it is directed towards the principal focus of a convex mirror. So after reflection will merge parallel to the principal axis. So in both the cases, for both concave and convex mirror, so a ray of light which is passing through the principal focus for concave mirror and directed towards the principal focus for convex mirror, after reflection will merge parallel to the principal axis. In the third case, let's see in which direction a ray of light gets reflected when it passes through the center of curvature. So this is the third rule for obtaining the images formed by spherical mirrors. When a ray of light passes through the center of curvature for a concave mirror, after reflection is reflected back along the same path. So you can see here the incident ray is reflected back in the same direction. That is, the light rays trace back along the same path because the incident rays fall on the mirror along the normal to the reflecting surface. In case of convex mirror, when a ray of light is directed in the direction of center of curvature, so this is a ray of light which is directed in the direction of center of curvature, after reflection is reflected back along the same path. Can you see here? This is also got reflected in the same path. The third rule is very simple, which says that whenever a ray of light is passing through the center of curvature or directed towards the center of curvature, the reflected ray is traced back along the same path. In the fourth rule, let's see in which direction a ray of light gets reflected when it is incident towards the pole. In case of concave mirror, when a ray of light is incident at the pole, as you can see here, it is reflected back making the same angle with the principal axis. That is, the angle of incidence made here will be equal to angle of reflection according to the laws of reflection. So the angle of incidence is between the incident ray and the principal axis, whereas the angle of reflection is between the principal axis and the reflected ray. In case of convex mirror, a ray of light which is incident at the pole is reflected back making the same angle with the principal axis. So again here angle of incidence will be equal to angle of reflection. These were the 4 important rules for obtaining images formed by spherical mirrors. Keeping these rules in mind, in our next video, we would be talking about the formation of different types of images by spherical mirrors. After watching this video, now you should have understood what are the rules for obtaining images formed by spherical mirrors. Thank you for watching. For more videos, visit our website videoteacher.schoolpage.me.